So, if you're wondering what I do all day as a geology PhD student, I spent the entire summer doing field work, and part of that was collecting some rock samples. And today, I'm cutting up a bunch of those rock samples, and not just today, but probably for about 3 weeks. So, let me show you a bit about what that entails. We start out with a boulder, so this is a piece of granite, and I have a bunch of them that are all different ages and from different locations, and I put them into a giant wet saw, and over a period of a couple of hours it can cut through one of those rocks and shows us what's inside. Of course, this is cool just because you get to see, the raw texture. If you look at the outside of the rock, there's a lot of weathering and this is exposed to the elements, so you can't really tell what it looks like and what it's made of. But once you cut it open, you can see the raw rock in its naked form, and it's just kind of cool as a geologist to be able to see that. But in addition to that, what I do is I cut this into a bunch of different pieces that are all different shapes and sizes, and I send it off to different labs to do all sorts of tests on the rock. Because what I want to know is what happens as these rocks get older. So this is one of our youngest rocks, and then we get a little bit older, and a little bit older, and a little bit older, and the oldest one is over there being sawed right now. You can probably hear it. And when I'm in the field, I'm looking at the cracks that you see on the outside of rocks. So you see there's like a little bit of a crack forming here. This one actually has quite a few cracks on it. And in the field, I'll measure hundreds of rocks in every crack that's longer than 2 centimeters, and I can start to understand how cracking changes through time. But once you crack the rock open, if you will, you can see that those cracks that we see on the surface don't necessarily reflect what's going on the inside. Because you see this crack here actually does not go to the surface. It starts forming on the inside of the rock. As you can see there, it ends. And if we look at the outside of the rock, there's no crack. So if we just saw this out in the field, we would say there's no crack in this whole area, but once we cut it open, we can see that there's actually a pretty long crack that goes around all the little grains that once it goes all the way through, will break off this whole section of rock. You see that over here as well. There's this nice long crack jutting around all the grains, and this one is actually almost going all the way to the surface. But again, if we look at the outside of the rock, you can't really tell. You would not have picked up that that was a pretty substantial crack working its way through the inside of a rock. And again, this is not forming on the outside from abrasion or something like that. This is most likely forming because when a rock sits out in the sun, it expands and contracts, and you end up getting these tensile fractures that already exist as weak points around the different grains, but then they keep growing because you're expanding and contracting and expanding and contracting. And, we go on. In the case of this rock, this one's about 6,000 years. It's been sitting on the surface of the earth. So 6,000 years of the sun heating and cooling can break the crap out of a solid piece of granite.